Hello guys, welcome back to KD Code. In this video, I will be explaining about a machine learning project that is weather forecasting. First of all, to know about weather, we have to get the data from real-time sources. So I have chosen a website where they provide the real-time data every day, every month, every year. So this is a website that is eastparksweather.net where they will provide data for East Park, Colorado. So here we will be getting all the weather data from January to December every year. Like you can see the average temperature, humidity, dew point, rainfall and pressure for every month. Every day we'll get all the averages and extremes. So if you go to the last end of the page, we also get the average and extremes for that whole month, like average temperature for the whole month. We'll also get it individually here per every day. So let's scrap this data. Scrapping in the sense we have to get data from this website using the classes and HTML content we have in this inspect. So from this we will get the scrapping. So from this we will get the data from scrapping, using scrapping. I have used the beautiful soup and request in Python to get data from that website using scrapping. So I took all the 21 variables we have in this website and I have written on in a list. I have used two for loops. One will iterate over each page for year, and also one will iterate over each page for month. Both combined will iterate over different pages and we'll be getting all the data from, you can see here, this is the year, so we'll be getting the data from 2005 to 2021 each month, like 1st of like January to the 12 like December. So we'll be getting data from January, that is 1st, until December, that is 12. We'll be printing the line here so we can cross check whether that page is getting scrapped or not. That's it. If you see the data here, you will be getting the values. I'm taking this value average temperature as key and the corresponding value as input. So this 27.6 Fahrenheit will be getting as an input to this average temperature key value. But if you keenly observe, we'll be getting all the raw data here. It is not in cleaned way. So I just taking it and making it into string values first. So afterwards I can clean it well and appending it to the corresponding list I have created before. After appending them, we'll be getting our CSV data. After getting them, I have converted them to a data frame. These are all the pages we have got the data from. We have scrapped all those pages. Then I have converted them to a CSV file here, and I commented out that line because in order to, if I run again, it shouldn't overwrite the existing CSV, so I have commented out. And then I have imported the same file again. I'm checking for the info for the data. So like we can check how many columns are there and what are the type of those columns, like that. So this is the unnamed column. It is the serial numbers, so it is not needed. We'll be dropping this column in the further steps. This is the year and this is the date, average temperature, and all the variables we have seen in that table in that website. we have scrapped all those data and stored it as CSV. We are having total 6033 rows. So we have different types of data like int, object, float, and object. What we are doing is the first step in the machine learning is to clean our data. So we'll be cleaning the data first and converting all the variables into int type data or float type data, because machine learning works with only numbers, not the characters. I'm using this describe function to know the count, mean, standard deviation, minimum value, maximum value, what is the middle value. So we can be knowing everything from this function. As I said, unnamed is nothing but a serial number, so I'm dropping it. We have started our data cleaning from this step. As you cleanly observe, our data is having the units placed as a foreign heat, and some other data is having percentage, and some other data is having degrees. So we'll be removing all these unnecessary units for the numbers and converting them from object to int values or float values, because the machine learning models will work with only numbers. I'm printing the shape here. It is 6033. Let's check for non-available values, that is NA values here. So I have used isNA function and dot sum to know how many non-available values are there for that variable. As you see, 150 rows are having non-available values. As it is a smaller number, it will not be affecting my model. So I have dropped all the 154 rows using this drop NA function, and I'm just saying whether they are dropped or not. I'm using the same isNA and sum functions here. So all are zeros here. So I can say every non-available values are dropped out, and I'm checking for average value here. I will be explaining what is this. If you keenly observe in the website, you can see there is one law. There are many tables here. For each day there is having one table. For each day we will be having one table here, and at last we are having average for all the month, average and extreme values for whole month. This is the values which we don't need, because this is the average values for every month. It will be giving at last table in the website. So we will be removing that values from our dataset. As it is, as the table starts with average character, I will be choosing this average and removing that rows from our dataset, because we are not dealing with the average values of whole month, rather than we are dealing with the everyday data we are getting from that website. After removing the NA non-available values and this average values, we will be left out with 5801 rows. And as I said before, to remove all the unit place values like foreign heat, percentage, and degrees, I have created a function that is change here. This will take care of that removing the units place. Like I'm checking whether it is the float value or not. If it is not, it will go to except block and it will check again with removing the lost character in that value. So we'll be having that units foreign heat or degrees, at least two characters, like degrees Fahrenheit and degrees Celsius or percentage. So at most we have two unnecessary units places. So we'll be checking two times here the try and except blocks, and rest we will get the numbers. Then I'm calling every column here. Then I'm iterating through every column here, and calling this change function to get the number values, numeric values, by changing them from object to float values. And then here I am appending that I'm assigning that numeric values in place of object values we have. Now you can see our data is very well cleaned up without any non-available values and unnecessary characters. And I'm using this info function to see whether every value is converted to int or not. So every value is converted to int or float. As you see, date will not be using date in our model. So I will be using the simple other variables here. Let's see. Before going through our models, we have to analyze our data using visual graphs. So I'm using Seaborn package, which we can draw the graphs pairwise. Like we can get all the graphs at one place for all the variables. You can see here there are 21 columns, means 21 variables. With 21 variables we'll be getting all these graphs. With 21 variables we will be getting all these graphs. So not to make it more complex, I just took 4 variables here. 3 variables: average humidity, dew point, a barometer as x values, and maximum temperature as y value. So I will be using the first 3 variables to predict the maximum temperature of the day. So this is the graph it is giving me. If I compare maximum temperature with average humidity, it is, I can say, whenever average humidity is more, the maximum temperature is getting decreased. It is having a constant decreasing relation with it. And if average dew point is increasing, the maximum temperature is also being increased somehow. I can say it is having the increasing straight line relationship with it. And if you see average barometer, it is constant every time, like 0, and sometimes it is 1000. I can say 0-1 relationship, like either 1000 or 0. So let's predict our maximum temperature using these 3 variables. Our first model is linear regression. This is the basic model we will learn every time when we start with machine learning. But if you see the linear relationship between the variables, you can use this model. As I said, the average humidity and maximum temperature and the average dew point and maximum temperature is having somewhat straight linear relationship. And using this model, so accuracy for linear regression is 85%. Let's check some other models here. This is for linear regression, for linear relationship. Now I will be converting the maximum temperature into the encoding types, like 0 or 1. So if I convert them to 0 or 1, I can use classification models on them. Using mean value, I am converting the maximum temperature to 1 and minimum temperature to 0. Like I'm assigning only 2, 1 or 0 values to the maximum temperature variable. I have made 2 new variables here. Temperature is, that is the maximum temperature encoded way, and the minimum res is the minimum temperature in encoded way. So this is the last data set I got. Temperature res, in the sense it is the maximum temperature. If it is 1, it is having higher temperature than its mean value. If it is 0, it is having less temperature when compared to mean value. So as I discussed, I will be applying these classification models now. So I'm using the seaborn pair plot here again, and I'm using maximum temperature that is encoded way. I'm using them as hue, so I can see where we are having the maximum temperature and where we are having the minimum temperature, that is the maximum and minimum temperature in the encoded way. Here I'm using temperature as a hue value, so I can differentiate between 0 and 1 encoded values for maximum temperature variable I have. If you see for average humidity and average dew point, the graph is linear and temperature is kind of two clusters, so I can use clustering also. But let's apply classification first. I'm using support vector emissions now. For this, I'm using temperature as the target value and other three as the dependent values. I'm using I'm using linear kernel here. I got an output with an 86% accuracy here. So for linear regression, I got 85%, and for SVM, I got 86%. So SVM is win here. And if I use if I use poly kernel here, I got 86% again. So the win is SVM here again. As we use Gaussian NB model here, you can see this is also a classification model. Here I got 82% accuracy compared to SVM. This is less, so SVM is win here again. And coming to random forest, this is also a classification model. It gives me 91% accuracy, so it is higher than SVM. So you can see the win is for random forest. And at last I have used decision tree, but it is slightly lesser than the random forest. If you see, the random forest is collection of different decision trees, so it will combine all the decisions for different decision trees and it will give us output. So practically speaking, the random forest will be having more accuracy than decision tree. So for decision tree I got 89% accuracy. The win is for random forest. Hooray! So this is a project I have done on web scraping. You can use not only these four variables, we can use any of the variables in that CSV file, and we can use any data from the CSV file and read the weather. We can use any variable basically. So this is the machine learning project I did, and I have created a UI for it using HTML code and CSS as front end and Flask as backend to connect the routes between the HTML files. So I have created three templates: weather.html, weather1.html, weather3.html, and one CSS file, simple pages and simple styling. With the routing, I have used Flask for routing with a simple three routes again to render each of the three HTML files along with the model predictions. Let's see it. I've already run it. Let's check it in the Chrome browser. If you see, there are many variables here that have got from the CSV file, that is from the web scraping. I can select four variables have done analysis on: average humidity, average barometer, and average dew point, and the maximum temperature as well. So here we are just selecting the variables we want to use for our model, to analyze our model. So just select them. After selecting, it will be asking you whether it is an dependent value or independent value. So we will be having one dependent value, that is y, and all our independent values, x values. Let's analyze the model. It will take some time and it will give us the accuracy loss. Let's wait for the models to analyze the variables. Yeah, we got the predicted models. So as we discussed the linear regression, SVM, Gaussian NB, random forestation trees in the Jupyter notebook, I have used the same models in the backend Flask also. With that, you can see the random forest is having 91% accuracy. So we can update our data in the Excel sheet and we can use the same variables here and we can just analyze the model. According to the data, it will give us the accuracy. We can even upgrade this project by creating one more HTML page, like taking input from the user for the input variables, and we can just print the output, that is the maximum temperature. We can update this project using such kind of pages. So that's it for this project. If you like the project, just comment out if you want to know anything else in this project, and if you have any other project titles, please comment down. I will be doing videos on them for such kind of final year project videos. Stay tuned to our channel. Please subscribe. Thank you.